The gas mileage m for a certain car is modeled by the function m of s equals negative 1/28 s squared plus 3s minus 31 for s between 15 and 70, where s is the speed in miles per hour and m is measured in miles per gallon. What is the car's best gas mileage and at what speed is it attained? Before we get into actually solving this problem, I want to talk about the situation that we're presented with. We're looking to find what speed a car has its best gas mileage. Now, every car is different, and when an engine is built, it's generally built to be optimized for a certain speed. Engines aren't going to work as well when you're going 90 miles an hour than when you're going 30 or 40 miles an hour, because you're really stressing the engine at 90 miles an hour. So engines are built in a way that tries to optimize efficiency for speeds that we might actually be driving at fairly often. And so one thing that they can do is they can actually test the gas mileage at different speeds, and they can use that data to get a model that represents the efficiency. And in this case, the model is represented by negative 1/28 s squared plus 3s minus 31. And that is accurate for speeds between 15 and 70 miles an hour. Oftentimes, when we're coming up with a model for something, we use data that we collect by running tests. Maybe they ran tests for a speed of 15 miles per hour, maybe they did 20, maybe they did 25, 30, maybe they did multiples of 5, and they graphed it and they used a computer to figure out, oh, it looks like these gas mileages are following along with this equation. And once they get an equation or a function that models what's going on, they can say, now let's use algebra to figure out more given this equation about the situation. So this is a quadratic function, and the leading coefficient is negative. So what this means is that the graph is going to be a parabola that's opening downwards. So our graph is going to look very vaguely something like this. And what we want to do is we want to find the best gas mileage, which is going to come from the maximum function value here. So if we can find the maximum function value, that tells us the car's best gas mileage, and then the S value, or the input value, tells us what speed that it's attained at. So we need to find the maximum function value here. Well, our function m of s is given by negative 1/28 s squared plus 3s minus 31. And it would be a bit of a painful calculation to go through the process of completing the square here, because we've got this fraction out front, negative 1/28. So instead of going through the process of completing the square and getting this in standard form, we're going to use the formula that we learned this lesson for the vertex. And remember, the x value comes from the opposite of b over 2a. And then to find the y value, which is going to give us our maximum function value, we just plug in the opposite of b over 2a to our function and figure out what the value is. So let's do this now. The x value of our vertex, which we usually represent with h, we are going to get that by taking the opposite of b over 2a. Now b is 3, so the opposite of that is negative 3 over 2 times a, so 2 times negative 1/28. Now, when we look at the denominator and multiply that, we can cancel out a 2 with a factor of 2 in the 28. We can reduce these by a factor of 2, and that's going to give us negative 1/14. Now, a negative divided by a negative is a positive. So this is going to be 3 divided by 1/14. And if we divide something by a fraction, it's the same as multiplying by the reciprocal. So this is 3 times 14 over 1, which is 42. So the x value of the vertex is 42. Now, if we want to find the y value of the vertex, which we usually represent with k, we need to evaluate our function at 42. So we need to take negative 1/28 times 42 squared plus 3 times 42 minus 31. And I'm just going to use a calculator here because there's no sense in writing all these calculations out by hand. And I get 32 as the function value. So our vertex is the point 42, 32. Now let's talk about what this means. Remember, the y coordinate of the vertex is going to be our maximum function value. So 32 is going to be the maximum gas mileage, or the best gas mileage, and that's represented in miles per gallon. So the best gas mileage is going to be 32 miles per gallon. And the x-coordinate is the input value that corresponds with that. Well, our function, the input value is speed. So 42 miles per hour is the speed that gives us this best gas mileage. So the best gas mileage is 32 miles per gallon attained at a speed of 42 miles per hour. So we know that we're going to be functioning at an optimal level, our engine, if we're going 42 miles an hour, and we're going to end up getting a gas mileage of 32 miles per gallon. If you've ever seen a car commercial that talks about gas mileage, and it says something like, oh, 32 miles per gallon is the gas mileage in a city. You might see city gas mileage. That doesn't mean that everywhere they get 32 miles per gallon. If we were driving on the freeway, let's say at 60 miles per hour, to find the gas mileage, we would have to substitute 60 in for our function. And if you do that, I've just done it with a calculator, you end up with about 20.4 miles per gallon. So we get a better gas mileage when we're driving on the city streets at 42 miles per hour than if we're driving on the freeway at 60 miles per hour. And this is why a lot of commercials will give the city gas mileage amounts, because it's going to be a bit higher than when the car is overexerting itself on the freeway.